Welcome to Pharmacology by Lecturio. Today's lecture is about elimination kinetics, how we get rid of drugs that are already in our body. My name is Dr. PJ Shukla. I will take you through this journey and hopefully we can learn something together. Let's talk about kinetics and the different type of elimination kinetics that occur. Zero-order kinetics is a constant rate of elimination. You can see that the concentration is very consistently going down over time. It is irrespective of the concentration, so the slope is not changing at all on this graph. First-order kinetics is a changing rate of elimination. So you can see that as we get lower and lower in terms of our concentration, you're getting rid of less and less of the drug. It is dependent upon concentration, and there's always a proportional decrease. Now, we have mixed kinetics in the real world, so you can see that there's actually two different slopes to this particular graph. So the first part of this slope is the initial distribution phase. That represents drug moving from the blood into the tissues. This is very rapid, and it tends to be what we call zero-order kinetics. The second portion of this curve is the elimination phase representing the removal of the drug. This tends to be a bit slower, and once again, for this particular drug, it's zero-order kinetics. We can have multiple mixtures depending on the individual drug. The half-life is a very important concept that we want to understand when we're looking at drugs. It is the time, whether it's hours, minutes, or a day, at which the mass or total amount of unchanged drug becomes half of the original concentration. So this, for example, is an example of a patient who has a half-life of about 2 hours. Now let's take a look at this with a question. Take a look at this graph. There are 3 drugs listed here. Let's start with the dark green. Question number 1. Drug number 1 has what type of kinetics? Is that a zero-order kinetic or is that a first-order kinetic kind of elimination? That's right, it's a zero-order kinetic, and that's because it's a constant rate of elimination over time. What about drug 2, which is the light green drug? That's right, first-order kinetics. And similarly, now that you've got it, drug 3 has first-order kinetics as well. So let's take a look at our answer. Drug number 2 has first-order kinetics because elimination is changing over time. The slope is not constant. But take a look at the concentrations. At 1 o'clock, the concentration was at 8. At 3 o'clock, the concentration was at 4. And at 5 p.m., the concentration was 2. So every 2 hours, the concentration is halved. That means that the half-life of drug number 2 is 2 hours. Remember that most drugs are going to follow first-order kinetics. Some drugs will follow zero-order kinetics. Let's look at drug 3. So drug 3 also has first-order kinetics. The concentration at 1 o'clock was 12. At 3 o'clock was 3, and at 5 o'clock was 1/2 of 1.5, which is 0.0625. Every 2 hours, the concentration was quartered. So therefore, the half-life is 1 hour, because at 1 hour, that concentration is halved.